It's Sunday night and well past my bedtime, but I needed to record a quick introduction to this video with Connor Green. We recorded over an hour and 20 minutes of a rambling conversation that only two ski nerds could enjoy. I've tried to edit it down to a more concise presentation. You'll have to forgive the herky-jerky editing because neither one of us speaks with a really predictable rhythm, and we're not very good at staying on track. So this video jumps around a little bit in an effort to present a cohesive message. Apologies in advance.
So I'm Connor Green. I'm a product engineer at Madshus here in Norway, and I'm responsible for a lot of the research and development that goes into our skis.
Right. And we're going to talk about the Redline 3.0 models that you guys are releasing this year. Mm-hmm. Can you very briefly describe sort of the material evolution? I'll give you like 30 seconds.
Yeah. So over the course of the past 2 years, we've been working on optimizing the material for the new geometries that were created with the start of Redline 2.0. Mm-hmm. And the new material kind of goes hand in hand with camber, which is what I assume we're going to get to after this, which is the biggest, can you say, source of variation?
Sure. I mean, the way I try to explain it to people is that the geometry of the ski and the material layup of the ski are drawing board variables. Once you guys set those, functionally the skis are the same. The stiffness is the same. Nothing really changes aside from the camber, which is kind of like the way you preload the spring. It's the specific shape of the ski that you guys put into it in the molding process. And it's like if we're selecting skis, if we travel all the way to Norway to select skis, what we're actually selecting are cambers.
Yeah. I think I'm pretty sure it was you that first phrased it this way, but the skis are all the same, but the camber changes how the skis' properties are expressed. It's nuanced.
Yes.
It's nuanced. It's very nuanced.
Well, every time you change one element of camber, you affect the way the others express. It's got to happen in balance, and the whole system really can't be pulled into separate parts. You can't change one thing without changing everything.
There pretty much isn't a variable that you couldn't give me where I could make two skis that both have the exact same value for that variable, be it half weight, full weight, whatever. One ski's great, one ski's horrible.
And this really gets to the point of why I wanted to get you on video here, because there's been a really big culture shift at Madshus in terms of the way the skis are produced.
Yes.
Historically speaking, skis are built to target end flex values. Is that an appropriate statement?
Yep. That's
what does that mean in practice when you're, if you guys are putting together a production?
Madshus, but I think my personal opinion is the ski industry in general is very hung up on these flex numbers because they've been pretty much the only, source of direct information from a lot of ski manufacturers that's printed right on the ski. It's easy for the consumers to see, and they can, get that feeling or understanding that the ski is made perfect for them, just for them. If you're producing your skis to match a certain flex, you're compromising other aspects of the ski that could be improved.
You quoted some economist who came up with some statement that put this out there.
It's colloquially known as Goodhart's law, to paraphrase it, a saying that says, when a measure becomes a target, it ceases to be a significant measure. It was the flex value that was basically steering production from the beginning. Right. That was the metric that became the target and then ceased to be a useful metric.
So the first time you mentioned that to me, the first thing I thought of was VO2 max. Having coached a lot of athletes and everything, I've seen so many circumstances where, the endurance sports world recognizes, say, the importance of a metric like VO2 max. Like, hey, all the best skiers in the world have these really high VO2 maxes. And then they design a training protocol to maximize VO2 max. So, this training, gives you the best increase in VO2 max of any training we've found. And therefore, this is how you're going to become a fast skier. And over again, these methods fall on their face. They fail miserably to produce really good skiers.
No, I don't think they fail. I think they do a very good job at what they're designed to do, increasing your VO2 max.
But I say they fail to produce good skiers.
Yes, and that's exactly the point. What are you trying to actually get out of the training?
So with respect to skis,
with respect to skiing, it would be to ski fast, not to have a high VO2. With respect to skis, that's always going to be a balance between different factors, which I think makes the task interesting. In general, the goal is always to have skis under your feet that get you from the start line to the finish line as fast as possible.
Right. Basically, you decided you were going to stop producing skis to specific target flex values and instead produce good skis. Like, how do you produce a good ski then? What's a good ski? How do you measure it? How do you decide what it's going to be? Yeah. What's your new metric?
That's a great question. So we, as any other ski manufacturer does, spend thousands of hours every winter testing skis on snow. We have tons of data. We have looked through hundreds of, or probably thousands actually, of different skis and seen qualities and material builds, laminate structures that time after time just work over a wide range of conditions for a wide range of skiers with different techniques, and they're just always good. Sure. So we started with that idea of what a good ski is, and essentially I've built a quality control system in the factory so that at every single weight range, we're always recreating a good ski as opposed to hitting a particular weight.
And you're checking this using the camber?
Yes, we're using the camber.
Okay. So you know what the shape is. You don't have to check the material because you built the skis. You designed them and built them. So you know what's inside.
Yeah. So we know what the tolerances are on all of the different laminates and the positioning and all that.
Right. So the reference point then becomes the shape of the ski, the shape of the arch of the ski.
Yes.
At your reference loads.
Yes, exactly.
That's a lot to control because rather than just loading the ski until you hit one benchmark residual camber height, you have to look at the entire ski at every load. That's a lot. How do you, if you're doing that on the fly, what's the system, or can you tell us how you guys are making those measurements?
Yeah, so I'm not going to say too much about how we're taking the measurements. Got to keep some secrets here. But in terms of, I guess, how we actually control the camber, I think there's a lot of things that Madshus as a company and structurally already had as an advantage, and this is before I came here, but we weren't necessarily utilizing our strengths as much as we probably could have. So because of the materials that we choose to make our skis with, they are very highly engineered materials. They're very standard from batch to batch. We can basically purchase the same materials in 1 year, 2 years, 10 years, and know that they're going to be plus minus a very small window in terms of material properties. So that's very much step one, is knowing that what we're putting into the ski is very low variation. Point two is that we have very qualified workers. So we produce our skis in Norway. Probably no better place in the world to be producing skis and know that every single person in the factory has grown up skiing, or at the absolute least, they watch skiing all the time. They have family that they get it. They understand. They've grown up, and it's cultural.
So you've broken the mold, if you will. Like it's a whole new sort of product, and you're not building to these specific flex values, but you are putting these skis into retail establishments.
Yes.
So how are you supporting your retailers to help get the
Mhm.
customers onto the right skis? Because this is a whole new issue.
Yes, that's a super, super important thing. So, what we're providing to shops is the half weight and full weight measurements. So, say you have a ski that is 80 to 90 kilograms skier weight. The full weight, the skier weight, is going to be measured from the middle of that range. So, 80 to 90, middle of that is 85. So, it'll be the measurement of the balance point with the load 14 centimeters behind the balance point. So 14 centimeters behind, you compress the ski to full weight, and then measure the height at the balance point. Now reduce that load to half weight, take the measure at the balance point. And now we also do that on the Redline classic skis at 8 centimeters behind the balance point.
So you're getting on the classic skis then 4 measurements.
Oh, sorry. Yes, it's 3. We're not printing full weight for -8.
Okay, that's halfway. So like a double pole setup position.
Yeah, exactly. And so kind of the point of these 3 values and what they're trying to mimic are the -8 half weight is imitating a double pole loading scenario.
Halfway forward. Yep.
Yeah. The -14 half weight is mimicking
Tucking.
tuck. Yes, tuck.
Yeah.
I can think of the Norwegian, but not the English. Mimicking tuck. And -14 full weight is in diagonal when you're kind of just, yeah, exactly. And so between those, and then also measuring on a bench whether or not, basically double checking that you have what we call locking under the ball of the foot or under the balance point.
How's it coming out? I mean, so you guys are making skis this way now. Are you satisfied?
Yes, I am super satisfied. The workers are all very satisfied, and we are very much excited to move in this direction with not lower models, but the other models in our lineup.
Cool.
Moving away from not just implementing this on the Redline on the top
Yeah.
models, but kind of, you call it trickle-down technology.